Alright, so in this problem, I have 9 to the power of x minus 3 to the power of x is equal to 12. So to solve this, I'm going to first start by rewriting 9 here as 3 squared. So now I have 3 squared to the power of x minus 3 to the power of x is equal to 12. Now I'm going to I'm going to rewrite 3 to the power of 2 to the power of x as 3 to the power of x to the power of 2. Because if I have something in the form a to the power of m to the power of n, this is also equal to a to the power of n to the power of m. So now I'm going to let 3 to the power of x equal to the variable y. So now if I substitute in y in for 3 to the power of x, I get y squared minus y is equal to 12. Now I'm going to subtract 12 on both sides, so then these two cancel out, and I get y squared minus y minus 12 is equal to 0. So to factor this, we have to find out which two numbers multiply to get negative 12. So a times b is equal to negative 12, and they add to get negative 1. So a plus b is equal to negative 1. Well, negative 4 and 3 work out because negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. So now I have y squared minus 4y plus 30y minus 12 is equal to 0. Now if I factor out y from y squared minus 4y, I get y times y minus 4 plus the greatest common factor of 3 minus 12 is 3, so I get 3 times y minus 4 is equal to 0. Now I'm going to factor out y minus 4. So I get y minus 4 times y plus 3 is equal to 0. So this gives me two equations. I have y minus 4 is equal to 0, and I have y plus 3 is equal to 0. So for y minus 4 equals 0, I get y is equal to 4. And for y plus 3 equals 0, I get y is equal to negative 3. So remember how we let 3 to the power of x equal y. So now I have 3 to the power of x is equal to 4, and 3 to the power of x is equal to negative 3. Well, 3 to the power of x equals 4. To solve this, I'm going to take the log on both sides. So then I get x times log 3 is equal to log 4, meaning x is equal to log 4 over log 3. Now for 3 to the power of x equals negative 3, you can't take the power of a positive number and make it negative, so there's no solution for this, and my only solution is log 4 over log 3. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x is equal to 7. So the first thing I'm going to do is I'm going to factor out 5 to the power of x from my left-hand side. So now I have 5 to the power of, 5 to the power of x times 1 plus 1 is equal to 7. 1 plus 1 is 2, so I have 5 to the power of x times 2 is equal to 7. Now I can divide both sides by 2. So I get 5 to the power of x is equal to 7 over 2. Now to solve this, I'm going to take the log on both sides. So I have log 5 to the power of x is equal to log 7 over 2. And if I have something in the form log a to the power of b, I can actually move my exponent b here to the front, so I get b times log a. So in this case, I have log 5 to the power of x, so I can move x to the front, and I get x times log 5 is equal to log 7 over 2. Now, if I have something in the form log a over b, this is equal to log a minus log b. So log 7 over 2, that's going to equal log 7 minus log 2. Now, I'm going to divide both sides by log 5. So then these two cancel out, and I get x is equal to log 7 minus log 2 over log 5. So, log of 7 here, this is equal to 0.8451. Log 2, this is equal to 0.3010. And finally, log 5, this is equal to 0.6990. So now I'm going to have x is equal to log 7 minus log 2, so 0.8451 minus 0.3010 all over 0.6990, meaning x is equal to 0.5441. Alright, so in this problem, I have x to the power of x is equal to 4 to the power of x plus 16. So the first thing I'm going to do is I'm going to take the ln, or natural log, on both sides. So now I have ln x to the power of x is equal to ln of 4 to the power of x plus 16. Now if I have something, if I take the ln of something in the form a to the power b, and I can move this exponent b to the front. So this can equal b times ln a. So in this case, I have ln x to the power of x. I can move x to the front, and ln 4 to the power of x plus 16. I can move x plus 16 to the front. So now I have x times ln x is equal to x plus 16 times ln 4. Now if I distribute the ln 4, I get x times ln 4 plus 16 times ln 4. Now if I subtract x times ln 4 on both sides, these two cancel out, and I get x times ln x minus x times ln 4 is equal to 16 times ln 4. Now I can go ahead and factor out x from here, so I get x times ln x minus ln 4 is equal to 16 times ln 4. Now ln x minus ln 4, that's simply equal to ln x over 4. So I have this is equal to 16 times ln 4. And now this is essentially saying that x over 4 is equal to 4 over here. These two are equal to each other. So if x over 4 is equal to 4, this means that x is equal to 16, because these two have to match up as well. So now to check, let me plug this in over here. So if I plug in 16 over here, I get 16, because x over here, 16 times ln, 16 divided by 4 is 4. So I get 16 times ln 4 is equal to 16 times ln 4. So this works. Now for method 2, method 2 to check, I have x to the power of x equals 4 to the power of x plus 16. X equals 16, so I have 16 to the power of 16 is equal to 4 to the power of 32. 16 is 4 squared, so I have 4 squared to the power of 16 is equal to 4 to the power of 32. meaning 4 to the power of 32 is equal to 4 to the power of 32. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 6 to the power of x is equal to 12. Now I'm first going to take the log on both sides. So now we have log 6 to the power of x is equal to log 12. Now if we have a logarithm in the form log a to the power of m, using the power property of logarithms, we can actually move this exponent to the front of the logarithm. So this would equal m times log a. So as you can see here, we have log 6 to the power of x. We can actually move this exponent x to the front of the logarithm. So this would be x times log 6 is equal to log 12. Now we want to isolate x, so I'm going to divide both sides by log 6. So now these two cancel out, and we are left with x is equal to log 12 over log 6, and log 12 is the same thing as log 6 times 2. We are dividing this by log 6. And log a of b, ab, this is equal to log a plus log b. So log 6 times 2, this is going to be log 6 plus log 2. And we are still dividing this by log 6. So now log 6 divided by log 6 is 1 plus, now log 2 divided by log 6. So log 2 over, now remember log 6 can, now we could rewrite this as log 2 times 3. And remember, log a of b is equal to log a plus log b, so this is going to equal 1 plus log 2 over log 2 plus log 3. Now I'm going to write the continuation up here. Log 2 is equal to approximately 0.301. Now we are dividing this by 0.301 plus log 3 is equal to approximately 0.4771. And now this is equal to approximately 1.3868. So x is equal to 1.3868. So that's our answer.